To my channel, here I have a question to solve on the construction of an ellipse. I'm going to read the question, then we'll go on and solve the question. The question says, draw an ellipse when the distance of its focus from its directrix is 50 millimeters and eccentricity is 2/3. Also, draw a tangent and a normal to the ellipse at a point 70 millimeters away from the directrix. I will take the question again. Draw an ellipse when the distance of its focus from its directrix is 50 millimeters and eccentricity is 2/3. Also, draw a tangent and a normal to the ellipse at a point 70 millimeters away from directrix. Now, let's go and answer this question. So, the first thing that we are to do is to position the directrix. So the directrix is a vertical line of any length. So I'm going to call it, so I'll call it AA or AB. So let me call it AB. Okay, so we have it to be AB then. Somewhere around there, I'm going to draw the axis. So I'll draw the axis of any length like this. So I'm going to call this point, I'll call it point C. So this is point C, and I'll call this point D. So now we are to fix the focus of the ellipse, so which is 50 millimeters away from the directrix. Okay, so we are to take a measurement of 50 millimeters for us to fix the focus. So I'm going to take a measurement of 50 millimeters from this point C to this side. So here we have 50 millimeters. So this point is the focus of the ellipse. So put F here. Now we need to position the vertex of the ellipse. We need to position the vertex of the ellipse, and to do that, based on what we are given as eccentricity of the ellipse. So we are told that the eccentricity is, so eccentricity E is equal to 2/3. So it's equal to 2/3, and this is equal to, we have this to be VF, so over VC, okay? So, which means that the position of the focus should be 2 divisions away from the vertex, and the position of the vertex should be 3 divisions away from the directrix from this point C. So which means that we are to divide this distance CF into 5 equal parts. So we are dividing this into 5 equal parts. It's 50 millimeters, so we just take it as 10 millimeters each. So so this is 10 millimeters, so this is 10 millimeters, so this is 10 millimeters, and this is 10 millimeters. Okay, so as I said, so the position of the vertex from the focus is 2 divisions away from the focus of the ellipse. So we are going to count 1, 2. So we are putting the vertex of the ellipse at this point. So here we have V here. Okay, so that is the vertex we have positioned it. So the next thing that we are going to do is that we are going to erect a vertical line. So at this point C, V here at the vertex, so just a short vertical line at the vertex, so it goes up like this. Then we take the compass and then we put the pinpoint at this point V here, and we extend it to point F. So that is the focus. So here we have this point. Okay, so we extend to this point F here. Then we draw an arc like this to touch this vertical line. So I'm going to call this point where the arc touches this vertical line, I will call it point E. So this is point E. So the next thing that I'm going to do is that I'm going to draw a line from point C on directrix, passing through point E, and then it goes in this direction. So this is what I'm saying. So from C, we are going to draw a line. So we draw a line. So from C, and it goes in this direction. Okay, so we have that. All right, so the next thing that we are going to do is that we are going to number this point. So I'm going to call this point, I'll call it point 1, and this point here I will call it point 2. It is 10 millimeters from V to this point is 10 millimeters, from 1 to this point 2 is 10 millimeters. So we are going to have some points on this line. So on this line on the axis, and then I'm going to make those points to be 15 millimeters. So I'm not going to make it 10. So I will make this is 15 millimeters from 2. So 15 millimeters from 2, then 15 millimeters from that point, again 15 millimeters, and then here we have another 15 millimeters. Then we have this point, this is 15 millimeters. So this point we have 15 millimeters, okay, and to this point, so let me just add one more. So we may need it or may not need it, so I'll just make this 15 millimeters. So let's chop it here for now. Okay, so next thing that we are going to do, we number this point. So I'll call this point, I'll call it point 3. So this is point 4, this is point 5, this is point 6, so this is 7, this is 8, and then this is 9. Okay, so we have all these points. So so this is 9. So next thing that I'm going to do is to erect a vertical line. So we are going to erect a vertical line on each of these points. So we start from here. So erect a vertical line here on 1 and also on 2. So we erect a vertical line. So on 3, so we draw from here down, and then on 4, so we draw from here down. On 5, so we also draw a line like this. So on 6, so we draw. So on 7, we draw a line. Then on 8, we draw a line. Then on 9, so I will extend this a little bit. So extend this line, so a bit to this side. Then I'm going to draw a vertical line for 9. Okay, so here we take this down. Alright, so we have this. So the point that we have on this line, I'm going to number them. So I'm going to call this point, this is point 1 prime. So this is 2 prime, this is 3 prime, here we have 4 prime, this is 5, this is 6 prime, 7, then here we have 8, and then we have for this to be 9 prime. Alright, so we have this. So the next thing that we are going to do now is to locate the points that we are going to join together to have the curve, that is the ellipse, in place. So the first thing that we are going to do is to put the pinpoint here at this point 1 and extend to 1 prime on this line. Okay, so on this line we extend to 1 prime on this line, then we lift it up, then put the pinpoint at F here, that is the focus, and make an arc on line 1 up and down of line 1. Then so we put it at 2 here, which is the focus. So we put it at 2, then we extend to 2 prime on this line. Okay, so we have this point, so just take it down, so to make an arc on line 2. Then for 3, so we put it at 3 here, then we extend to 3 prime on the line here, then we raise all this up, put the pinpoint at F, and then we make an arc here and here on 3. Then we put it at 4 here. Okay, so we extend it to 4 prime on this line. Okay, on this line, then we raise it up, so put it at point F here, so make an arc on 4 up and down. Then we put it at 5 on the axis. Okay, so we extend it to 5 prime, extend to 5 prime. Okay, and then so we raise it up, so we put it at F, and we make an arc on line 5 up and down. Okay, then we put it at 6. Okay, we extend to 6 prime on the line. Okay, then so we raise it up, so we put at F here, so make an arc on 6 up and down. So next, so we have 7. Okay, so we extend it to 7 prime on this line. Okay, so here we have So we have this point, so we raise it up, put the pinpoint at F here, and make an arc on 7 up and down. So the last one is 8, so we put it up probably, so we extend to 8 prime, okay, so this is it. Then we raise it up, we put it at F here, and make an arc on 8 here and here. So looking at what we have here, so I can see that, so this will be the last point. So if I'm to take for 9, so it will be somewhere probably to touch this point, so we just leave it here like this. So this is point, so this point here now is the second vertex. So let me just take the distance. So if I take from 9 to 9 prime here, to 9 prime here on this line, this is the point. So we raise it up and put it at F here, then so you can see that, so it almost touches. So so we have this point here, okay, so this point here will now be the, so it's important I take it. So this point now is the second vertex, so we have V2 here, while this one is V1, okay, so let's take note of that. All right, so now that we have located the point, so we are going to let's bring out the point. So we have this point here, so there's a point here, so we have this point, so there's a point here, so we have this point on this line, so there's a point here, we have a point here, we have a point here, then point V here, so that is V1, so we have this point, so we have this point, so this point, so we have a point here, so we also have a point here, so there's a point here, so there's also a point here, and then we have another point. So we are going to join them together with the use of a French curve for us to obtain the ellipse as we are given. So so this is my French curve, so we have to adjust it for us to be able to join the point together. So this can go like this to this point. All right, so we have this. So and then, so if I come to this side here, okay, so we have to adjust it. Okay, so we join this point together. Okay, so we join to this point. All right, so and then for this part, so I'm going to adjust, and then join this point together. So we have that part drawn. So then we come down here, so we set like this. So you adjust, so the French curve, okay. All right, so I can go this way, okay, so it goes this way. All right, so we have that part drawn. So next, I will turn it to this side like this. Okay, so adjust it for us to see the point that we have to join together. Okay, so I can go this way. Alright, so then the last part is here. So I'm joining this point together. Okay. Alright, so we have formed the ellipse as you can see here. Alright, so the next thing that we are going to do is to draw the tangent and the normal, as we are told that the tangent, the point where we are going to put the tangent is 70 millimeters away from the directrix. So this is directrix, as I said. So we are taking a measurement of 70 millimeters. So 70 millimeters. So from the directrix, so setting it the ruler like this. Okay, I will take 70. So this is 70 millimeters at this point here. So here I'm going to draw a vertical line from this point. Okay, so I'll just take a line from this point to touch the curve. So it touches the curve at this point. So this point now is the point where we are going to pull the tangent. So I'm going to call this point, I'm going to call it point P. So this is point P. So now the next thing that we are going to do is that we are going to join our PF together. So we join PF together like this. So join PF. Okay, so then the next thing that we are going to do is that we take our protractor and then we set this midpoint of the protractor should be on point F, and while this line on the protractor should be on line PF. So we set like this. Okay, so we set like this. Okay, then so along this line where we have 90, so this line that goes to 90, so we put a dot on the paper like this. Alright, so then the next thing that we are going to do is that, so we have to draw a line from F passing through the point that we just put on the paper, so it goes like this to touch directrix. Okay, so now, so this point, so where this line touches the directrix, so I'm going to call it point F. Okay, so what I need to do now is to join F cannot work there, so I'll call it point G. So I'll call it G. I already have F as the focus, so that is point G. So I'm going to draw a line that will join PG together, and that line will be a tangent. So we just set like this at G and P, then we draw the line, so like this. Okay, so make it a thick line. So I will call this end of the line, I will call it H. So line GH is the tangent to point P on the ellipse. Then for the normal that we're asked to draw, so a normal is a line that's at angle 90 degrees to the tangent. So we have to set our protractor, so the midpoint should be on point P, and then this line on the protractor should be on GH. So we set like this, and we put a dot on the paper like this. So we put a dot on the paper. So here we have what we have this point. So what I'm going to do now is to draw a line. So we draw a line. So I will draw a line from P, so passing through the point, and then so it goes like this. Okay, so I can make this line, so I'll make it a thick line from here to here. Okay, so I'm going to call this line, so I'll call this Q. Okay, so then I'll call this Q prime. Okay, so this line Q prime is the normal, while GH is the tangent. So this is how to solve this question as you have seen it here. So thank you, keep on practicing, and God bless you.